Okay, hope you can hear me. Today I will explain basically some concept of supervised learning called neural networks. So, a neural network is basically a universal function approximator. So, every neural network consists of, many neurons, but fundamentally, for a single unit neuron, there is one circular structure. You can visualize it like that. Input gives output based on an activation function. So the activation function can be anything. So you just take x squared as f of x equal to x squared. So any x into the f of x will give you x squared. That could be an activation function, but usually neural networks use activation functions such as rectified linear unit or sigmoid, tan h, and stuff like that. So, because of the limitations of feed forward neural networks, which only has one forward push, neural networks with back propagation, which uses multivariable calculus, was introduced. So, back propagation is before that, we can talk about feed forward neural networks. So, each neuron is connected to another neuron with a single link which has a weight. So our job is to optimize these weights, biases, and other things. So like all of this is basically matrix multiplication. You can just visualize it using, not visualize it, understand it using linear algebra. So because of the limitations of feed forward neural networks and stuff like it cannot solve non-linearly separable problems. Can only solve linearly separable problems. So because of that, maybe multi-layer perceptrons, and this is not perfect understanding, but and back propagation was introduced. So back propagation at the end of each, so you iterate a neural network over various epochs, and at the end of each epoch you construct a cost vector which consists of all the neural network parameters. So suppose for an MNIST dataset it could be something a 10,000 dimensional cost vector. Now you have to reduce the error rate of the cost vector. You do this using gradient descent. So basically a gradient is the direction of steepest ascent, Nabla operator or something. So a negative of a gradient is the direction of steepest descent. So you optimize the cost vector, find the local minima and start the next epoch, so on and so forth. Calculate the accuracy until you have reached a sufficient amount of accuracy. So if you want to learn about neural networks, I would suggest the best option is 3 Blue 1 Brown on YouTube. His neural network series is absolutely phenomenal, and I learnt everything from him. And one more is coding train. He teaches you how to code Doodle classifier in JavaScript, but I converted it to Python, so you can do something like that. Okay, then thank you.